My name is Sam Woomer, and I'm from Lexington, Kentucky.
Hi, my name's Celeste Parent, and I'm from Houston, Texas.
Hi, my name's Andrew Jones, and I'm from Houston, Texas.
Hello, my name is Maggie Ross, and I'm from Wichita Falls, Texas.
My name is Meredith Lester, and I'm from Mandeville, Louisiana. The Lewis-Stuart Field Analysis Project focuses on determining which tertiary process recovery, carbon dioxide flooding or gas flooding, will perform better in the field and recover the most oil. The project will include a full field study, as well as a carbon dioxide analysis, a gas flood analysis, and an economic analysis of each flood. Available field data considered in the analysis includes historical well information, production records, vintage well logs, several modern-day well logs, sidewalk core data, and 3D seismic interpretation. Each member in the group is held responsible and accountable for inputs, contributions, project goal fulfillments, and requirements. Also, each member must be present at scheduled meetings and participate in required video presentations. All project management dates and deadlines need to be followed accordingly.
The scope of our project consists of collecting data from our group sponsor, Dwight Ross. Once the information was obtained, the team began to analyze it in order to fully understand the field. After all data has been analyzed, we will begin to run the simulations on the Lewis-Stuart field, simulating both a natural gas flood and a carbon dioxide flood. After the simulations are run, vital production information will be obtained in order for a cost analysis to be run on both types of floods. After costs have been evaluated against potential revenue, a recommendation will be made and delivered to Creed Operating Company. The milestones of the Lewis-Stuart Field Analysis Project are first acquiring data from the project sponsor Dwight Ross and researching both natural gas flooding and carbon dioxide flooding. This will be accomplished by December 4th, 2015. Next semester, the project will begin, and our second milestone will be to complete the history study on the Lewis-Stuart field. During this time, the group will be analyzing all documents received by Dwight Ross in order to better understand the field. The third milestone is to complete both the natural gas flooding simulation and the carbon dioxide flooding simulation by March 31st, 2016. The fourth milestone is the economic analysis, which is set to be completed by April 20th, 2016. The last milestone to complete in the Lewis-Stuart Field Analysis Project is to present the project deliverables to Creed Operating Company. This is to be completed by May 2nd, 2016, and will include all information gathered during the duration of the project, as well as a recommendation of future action on the Lewis-Stuart field.
The work breakdown structure is composed of work packages that were formed from our team members and our industry sponsor. Examples of these work packages include project presentations, meeting agenda and minutes, the progress report video, and the project management plan. The length of these work packages depend on their complexity. The work breakdown structure contains first semester goals and second semester objectives. As shown, our initiation tab includes the brainstorm of topic ideas, the development of the project charter, and deliverables of the project charter. The change management plan will map out the step-by-step order in which our group will handle deviations in our project. Keeping this step-by-step process consistent will help the implementation of change into our project. The 4 steps include 1. Identify change. The requester will identify the need for change. 2. Evaluate the potential change. The industry sponsor and the team will evaluate the need for this change. 3. Agree on the need for change. We will all agree or disagree to accept this change. Implementation. If we all agree, the change will be put into our project. The communication management plan serves as the framework for communication amongst the group. The project team directory provides the contact information for all group members, while the communication matrix will be used as the guide for what information will be needed, who will do the communication, and when to communicate the information.
This project has minimal to no costs. The project consists of gathering a variety of information from Creed Operating Company of the Lewis-Stuart field. This information consists of a field background, including production history, seismic data, reservoir parameters, etc. All this data has been obtained for no cost from the project sponsor, Dwight Ross. The next component of this project is using a reservoir simulation program which will be accessible free of charge from Louisiana State University. This program will be used to simulate both a carbon dioxide flood and natural gas flood of the Lewis-Stuart field. The completed simulations will aid Creed Operating Company in making a decision of what type of tertiary recovery will be optimal. Listed are some of the cost factors that will influence the decision between natural gas and carbon dioxide flooding. This project requires no procurement, but in the event procurement is required, the project manager will work with the project team as well as the project sponsor to identify all items or services to be procured for the successful completion of the project. If procurement becomes necessary, the project sponsor will be responsible for the management of any selected vendor or external resource. The project sponsor will also measure the performance relating to the necessary goods and/or services and communicate this to the project team.
The project manager, Maggie Ross, will be of sole responsibility of the project scope. Maggie will provide and establish guidelines for measuring project scope and will approve documentation including deliverable quality checklists and work performance measurements. The scope of this project is focused on evaluating all given field information and will result in an educated decision of whether or not to perform tertiary recovery methods. Production from the field still holds potential to be economical with tertiary recovery methods. Reservoir simulation and computer software will be used to compare a carbon dioxide flood to a natural gas flood. The boundaries and scope for this project are limitless, and almost all field information is obtainable. The schedule management plan is based around several factors, but primarily focuses on the availability of project team members as well as the project sponsor, Dwight Ross. The approach taken is to ensure that the entire project team meets at least once every week of the semester. When scheduling a meeting, a plan is put into place to ensure all team members come with prepared material and are informed on what the meeting will entail. Once the team members and project sponsor agree to the assignments, durations, and schedule, this will be used as the baseline timetable for the semester. Each team member is also responsible in ensuring his or her part is completed in the allotted time. Overall, the schedule management plan will be one of the most important factors to the completion of a successful project.
All members of the Lewis-Stuart Field Analysis Project will play a key role in quality management. Team members will understand what project standards consist of, what is acceptable quality, and what defines critical success factors. The project sponsor is responsible for reading and approving all project work. Quality control processes will be followed to ensure all work and project deliverables meet requirements and quality standards. This process will include having each team member separately evaluate the work's quality. Quality assurance for the project will ensure that all listed quality control procedures meet satisfactory standards and will ensure work is in fact of acceptable quality. The quality control procedures must be followed so that errors can be avoided.
The risk management plan will follow a series of steps: identification, ranking, monitoring, and avoidance. In the identification stage, team members will identify possible risks that could develop during the course of the project. These potential risks will then be ranked based on their potential impact to the project. After the potential risks have been identified and ranked, the risk monitor sponsor, Meredith Lester, will be in charge of monitoring for risk warning signs throughout the duration of the project. If she sees a risk warning sign, it is her job to alert the project sponsor immediately so that action can be taken to avoid the risk from developing into a problem that could potentially be damaging to the project in time or quality. Risks that have been developed so far include lack of adequate data to run the reservoir simulation software. Also, since none of the team members have worked with simulation software before, it will be crucial to research the software and obtain a mentor that can guide the group through the software program.
The project will consist of a simple work structure. All work will be performed internally. Staffing requirements for the project include the following: a project manager, a project sponsor, a project mentor, and 4 engineering students. The Lewis-Stuart Field Analysis Project is scheduled to last roughly 5 months. The project will require the continued work of all team members throughout the duration of the project, with other resources varying in necessity over time.
The cost baseline for the project will be managed as need be. Being an already explored and developed field, almost all costs and investments have been taken care of. The field already contains facilities and several wells in good condition. The facilities for the tertiary recovery processes are already in place. The field is easily accessible to be operated with minimal cost to be recorded. The project sponsor feels as if the cost baseline for the project will be minimal.
The quality baseline is the standard baseline that is set so that project work meets quality standards. The baseline ensures quality control and quality assurance procedures and can be used in quality monitoring. The project must meet or exceed quality baseline standards listed in the table so that the project can be considered successful.